Let's talk about radicals and radical expressions. And to start that, I'd like to go through some vocabulary, just making sure you're familiar with the terminology used in the components of a radical. So this entire symbolism that you see here is called a radical. The n is the root or the index. What's inside is called the radicand. It's what you're taking the root of. And this last piece, the actual symbol that looks like this, that's just the radical symbol. Now, up to now, you are probably used to using just square roots. But in this video and those that follow, you're going to see that the index, which I'm also going to call the root, can be more than a square root. We can take a cube root or a fourth root or a fifth root, etc. Below that, you will see a table, and what I have listed is the first several perfect squares, perfect cubes, and perfect fourth power numbers. Now, this is not something that needs to be memorized, but you do need to be familiar with these numbers so that when they show up, you recognize them as being a perfect power of a base number. So the perfect squares go from 1, I did down to 12 squared, which is 144. The perfect cubes, which would be 1 times 1 times 1, 2 times 2 times 2, etc. I only did up to 512. You notice they get big very quickly. So 8 times 8 times 8 is 512. And the perfect fourth powers obviously are going to get bigger even faster. So I only took it up to 5 times 5 times 5 times 5, which is 625. So let's just practice by taking the root of some of the numbers that are in this chart. So the cube root of 64, here's 64, its cube root is 4. Cube root of 125 is 5. The fourth root of 16, so if I go down to the fourth power, 16 is 2. And that is because, and I'm writing this one because it's tempting to put 4 there, because 2 times 2 times 2 times 2, so it's used 4 times, is equal to 16. Cube root of a fraction, a giant cube root is the same thing as 2 small cube roots of the numerator and the denominator separately. The cube root of 8 is 2, and the cube root of 27 is 3, so the cube root of 8/27 is 2/3. Now let's talk a little bit about the difference between positive and negative roots and principal roots. So when you look at example 2, it says find each root that is a real number. Now for now that may not have a lot of meaning, but later it will. So when we look at 100, if you see nothing but just the root sign, the radical sign, and a number underneath it, then we are looking for what is called the principal root, meaning the positive. And that would be 10, because 10 times 10 is 100. Also notice, when you don't see an index, I'm going to write this bigger, when you don't see an index there, it's always implied that it is a 2 or a square root. When you see the negative outside of the radical sign, it's called the negative root. So what I want to know is, what is the negative of the square root of 10? Well, the square root of 10 is, 100, excuse me. Square root of 100 is 10. The negative of that is negative 10. And if you think about it, negative 10 times negative 10 also equals 100. But we indicate that we want the negative root by putting that square root sign and the negative sign on the outside of the square root. Fourth root of 81, if I go up and I look at my fourth roots, you can see that that is 3. This is a principal root because we want the positive, whereas negative fourth root of 81 is negative 3, and that is called a negative root, just so you know the difference. Now, let's look at a cube root. I can take the cube root of negative 8. I don't have to put the negative outside. I can actually have the negative symbol underneath the radical sign if the root is an odd index. And the cube root of negative 8 is negative 2, because negative 2 cubed is negative 8. So in this case, I can actually have the negative sign under the radical, and again, it's because my index is an odd number. So 3 odd negatives makes a negative. Cube root of positive 8 is positive 2. So every odd index, meaning the 3 or a 5, 7, etc., has exactly one real root. It could be positive, negative, or 0, depending on what number is underneath. If the index is even, like this, a 4, then it makes no sense to have a negative sign underneath, because there is no number that if I raise it to an even power, I'm going to get a negative number. That doesn't exist, because the negative signs, if there's an even number of them, are going to pair up and make it positive. So we would say here that this is not real. So I want to reiterate this again. I can take the cube root of negative 8. That's not a problem, because that means what 3 negative sign numbers multiply together to make a negative. That can happen. That's negative 2. But I cannot take, let's just use a square root, an even root, even index of a negative number. That is not real. It doesn't exist that there is a number that when multiplied times itself, if it's negative, is going to give me a negative answer. It's always going to give me a positive. So this is key right here. Let's take a minute and look at finding roots on a calculator. And I'm actually going to use a Texas Instruments calculator. If you have a different kind of calculator, it may be a little different. I'm actually going to put my calculator down here. I don't know how well you'll be able to see this, but you should at least be able to see the button pushing. And then I have described the button pushing right here. So let's say you want to take the 4th root of 16. So I want to take this, the 4th root of 16. I'm going to turn my calculator on. It says what you do is you're going to first type the 4 into the calculator. This is a little bit counterintuitive, but you enter the roots you want to take. So I'm going to type in a 4, and I do think you can see that okay. And then I'm going to go down here to where it says math, the button that says math, which is going to give me a menu. And if you notice on this menu, number 5 shows something that looks like this, the xth root of. Now, because we entered the 4 first, it means that we are indicating that we want that 4 placed in that x spot. So I'm going to select that I'm taking the 4th root by picking number 5 on my calculator, and all I have to do that is just push on the 5. Now, depending on what operating system you have, it may or may not pop that 4 up there that you entered into the index position. I'm going to scoot this over a minute and kind of show you what some calculators do. If your operating system is older, when you type in the 4 and then you select math and number 5, it's still going to look like this. And this is weird because it's not really what we mean, but it's indicating that we want the 4 up there. My operating system has been updated, so it actually placed my 4 up there in the index position. So don't be confused by that. If it leaves the 4 out front, once you make this selection, it means that you know you want the 4 up there. Now all I have to do is type in the number that I want to take the root of. I'm going to type in 16. Now I could continue to type if I wanted to make the number bigger, but if I hit enter, it's going to assume that I am finished. So I hit enter and it tells me 2. So right here in your notes are the button pushing directions for how to take a root that's not a square root on your calculator.